So lesson 1.5 is going to now talk about infinite limits. We're going to cover this over a 2-lesson span. So we're going to just review rational functions because that's predominantly where these come into play in terms of one-sided or infinite limits. But we're going to sketch the function 3 over x minus 2 and identify any points of discontinuity. So if we look at this function, we know x cannot equal 2 because that would make the denominator equal to 0. It does not cancel, which means that this is a non-removable vertical asymptote at x equals 2. Okay, so we're going to go to x equals 2 and we're going to draw ourselves a dotted line. And then we're going to pick values to the left of 2 and to the right of 2. And what you're going to find is this sketch is going to give you something along these lines. Okay, so again, all you're doing is picking values to the right and to the left, and the easiest thing is just decide what the sign is of the function in terms of the y value, and that'll identify which quadrant your point is going to be in. So now if we look at this and we say, okay, using the sketch, now we're going to talk about limits. So we're going to say the limit as x approaches 2 of f of x. So if it's approaching 2, here's our 2 value. Well, maybe we should focus on well, let's see. So as we're coming from this side down here, we're going towards negative infinity. As we're coming this way, we're going to positive infinity. So that's approaching 2 different values. So in this case, the limit does not exist. And we can just say approaches 2 different y values. 2 different y values. You don't want to say it approaches without bound just because it's not the same infinity, whether it be positive or negative. So it's approaching 2 different y values. Now, if we're just focusing on the right aspect of it, though, we're approaching positive infinity. And if we're just focusing on the left aspect of it, we're approaching negative infinity. In the past, we've always been able to say limit does not exist because it's approaching without bound. But now you're actually, starting with this section, you're going to be able to give positive and negative infinity as an answer. So a limit in which the function increases or decreases without bound as x approaches c, this is called an infinite limit. Okay, so we're going to determine the limit of each function as x approaches 1 from the left and the right. So I'm going to sketch each one of these just so we get a visual of what they look like. But in A's case, and they're all very similar graph-wise. So with A, we know we can equal 1. So it doesn't cancel, so that's a vertical asymptote. It's going to give off the same appearance that the one did right above. Okay, and now the question is asking us, we want to know the limit as it approaches x from the 1, or as x approaches 1 from the left and the right. So we have the limit as x approaches 1 from the left, and we have the limit as x approaches 1 from the right. So we're going to do both of them. So as it's approaching 1 from the left, coming towards 1, okay, it's always going to be approaching 1 because that's what the directions say, we're approaching negative infinity. Coming from the right-hand side, we're approaching positive infinity. So if we were to say what is the limit as x approaches 1 in general with no direction on it, then you would say limit does not exist. Let me jump down to C. So it's the same function, you just see a negative thrown on top, so you still have a vertical asymptote. The only difference is the placement on where your curves are, they're actually going to flip. So we're going from sort of, think of it like the first quadrant down to the fourth quadrant, and we're going from the third quadrant up to the second quadrant. And you'd get the same idea as if you subbed values in. If you sub any negative value in, you're going to end up with a positive value, so you have to be above the x-axis. So here, if we're doing limit as x approaches 1 from the left and limit as x approaches 1 from the right, what you're going to find is as you're coming from the left, this one is now going to be positive infinity, and coming from the right, that is now going to be negative infinity. In terms of B and D, it's the same function, you just see that extra square component thrown into it on the denominator. So you still have a vertical asymptote at 1. But now what you're going to find is when you plug values in, it doesn't matter what value you plug in, you are always going to get a positive answer, which means both of your curves are going to be above the x-axis. So now when we take the limit as x approaches 1 from the left, and the limit as x approaches 1 from the right, you're going to find out that they are both going to be positive infinity. Therefore, in general, approaching 1 would also be positive infinity. And for D, still vertical asymptote at 1, the only difference is because of that negative in the numerator, your arches are going to be going down like this. So now the limit as x approaches 1 from the left and the limit as x approaches 1 from the right is going to be equaling negative infinity for those. Okay, now second thing we're going to talk about is going over vertical asymptotes. So before I get to that next video, let me just see. So on the bottom it says definition. So if f of x approaches infinity or negative infinity as x approaches c, then x equals c is a vertical line. So it's easier almost to think of the algebraic way of how we go about this. So don't necessarily, if that wording is definitely confusing, the whole idea of a vertical asymptote is that when you factor, if something does not cancel and you have a variable left in the denominator, then there is some value that is going to give that function a vertical asymptote at